Hi everyone, I am Bhavna, 5th semester, Electronics and Communication Department of Sri Venkateshwara College of Engineering. Today, let us deal with the subject Computer Communication Networks. In that, let us deal with the topic Random Access Methods, in that, ALOHA. Introduction. ALOHA random access is a widely used technique for coordinating the access of large number of intermittent transmitters in a single shared communication channel. In an ALOHA channel, each transmitter sharing the channel transmits data packets at random time. In most ALOHA channel, the transmitters then rely on some protocol such as repetition to handle the case of packets lost due to the interference by other packets. An ALOHA channel may also just provide a better effort delivery mechanism and leave it to the receiver to deal with lost packets. History of ALOHA. ALOHA channels were originally analyzed and implemented in the ALOHA net at the University of Av in 1970. The ALOHA net utilized UHF radio channels to connect computer resources on the islands of Oahu, Manu, and Awac in a state of Awac. Since the 1980s, ALOHA has been the primary random access mechanism utilized by mobile telephone networks, satellite data network, DOCSI-based cable data networks, Ethernet, Wi-Fi, and WiMAX. Types of ALOHA. ALOHA is basically of two types. The first one is pure ALOHA and the second one is slotted ALOHA. These are the two types of ALOHA. The first one is pure ALOHA. The original ALOHA protocol is called pure ALOHA. The idea behind the protocol is that each station sends the frame whenever it has a frame to send. However, since there is only one channel to share, there is a possible of collision between frames from different stations. Figure 1 shows an example of frame collisions in pure ALOHA. So this is a figure 1 which shows the collisions occurring in the pure ALOHA. So there are four stations in the above figure that contend with the other for access to the shared channel. The figure shows that each station sends the two frames. There are a total of 8 frames on the shared medium. Some of these frames collide between multiple frames are in contention for the shared channel. Only two frames survive, which are frame 2 of station 2 and frame 1 of station 4, but others are lost due to the collision. Thus, the station need to resend those collided frames. So, it's a graphical representation of it through output of pure ALOHA. Here, the ALOHA protocol comes in action if all the sender sends the lost frames again together, then they can be collision again. Hence, ALOHA protocol says that the senders wait for a random amount of time. This randomness helps to avoid further collisions. We can call this back of time. Let's understand the protocol where TP is a propagation time, TB is back of time, TFR is frame transmission time, K maximum is equal to 15 normally. The second type of ALOHA is slotted ALOHA. Slotted ALOHA is a modified version of pure ALOHA where we divide the time into slots of TFR. Thus, if a station fails to send the frame in one slot, it can't send throughout that slot and have to wait for the next slot beginning. Thus, successful reduce the vulnerable time down to TFR, which was previously 2 into TFR for the pure ALOHA. Through output also increases and turns to be G into E minus G, where the maximum through output becomes 0.368 when G is equals to 1. Comparison of pure ALOHA versus slotted ALOHA. The comparison between the pure ALOHA and slotted ALOHA is done as follows. In the pure ALOHA, any device can transmit data at any time. But in slotted ALOHA, every device sends data at the beginning of the time slot. In pure ALOHA, single efficiency is 18.4%, whereas in slotted ALOHA, double the efficiency 36.8%. In pure ALOHA, vulnerable time is equal to transition time, but in the slotted ALOHA, vulnerable time is equal to 2 into transition time. ALOHA, the earliest random access method, was developed in the Union AVAC in early 1970. It was designed for the radio wireless line, but it can be used on the any shared medium. So it is a different graphical representations of pure ALOHA as well as slotted ALOHA. It's a graphical representation of both types of ALOHA. Analysis of the pure ALOHA. Since S represents the number of good or succeed transitions per frame time and G represents the total number of attempted transitions per frame time, then we have S is equal to G into probability of good transition. The through output of the pure ALOHA is S is equal to G into e power minus 2G. The maximum through output S maximum is equal to 0.184 when G is equals to 1 by 2. Pure ALOHA offered load versus the through output. So it's a graphical representation where through output versus the load. It's a graphical representation of the pure ALOHA. Through output of slotted ALOHA, the probability of number collision is given by P of 0 is equal to e power minus G. The through output S is equal to nothing but S is equal to G into P naught, nothing but G into e power minus G. The maximum through output of slotted ALOHA is S maximum is equals to 1 by E, which is equal to 0.368. So it's a frame in the slotted ALOHA network. We have station 1, station 2, station 3, station 4. The collision decision, how it's taking place in the slotted ALOHA, can be clearly seen in the particular frames. Conclusion: collisions and data frames may be lost during the data transitions over the multiple stations. There is no need for carrier sensing. ALOHA has no collision detection because the acknowledgement of the frames exists. It necessarily data retransition after a random amount of time. So it is one of the representation of the pure ALOHA, the graphical representation, how it takes place by the combination of both pure as well as the slotted ALOHA. Thank you for the session.